Hello and welcome to College World. Now we're going to proceed with our C4 tutorials, moving on into our fifth chapter, which luckily is the chapter before the last. You're one chapter away from solving all your past papers and getting ready for those exams. So, what is the fifth chapter? In our fifth chapter, we're going to discuss something called vectors. If you previously studied them, then you'd have a small background about them, and you probably just want some clearance. If this is the first time you're listening to them, even better, because I'm going to let you know all the properties, all the cases that you might approach in vectors. Now, something interesting about vectors is that you did not meet them before, neither in C1, C2, or C3. It's completely new, but you're going to move on to use them in physics, in mechanics, M1 and M2, if you're going to do those, and it's always used in so many fields. So it is very important in our real world because we can approach it in all subjects, and well, because they give us a sense of direction, which gets us to the definition of vector. What are vectors defined as? Well, first of all, let us go to the basic before vectors. If you know what a scalar quantity is. Now, a scalar quantity would be, let's say you have me here, and I tell you I'm 20 meters away from you. Now, if you want to know, if you want to draw on the drawing where I am, you can say I'm 20 meters here. I'm 20 meters here. Or you can say I'm 20 meters behind you. And technically speaking, I can be anywhere on that radius. I'm not going to be so good at drawing a circle here, but let's just assume it is. So yeah, I'm 20 meters close to you. So there's this radius. That's what a scalar quantity gives you. It only provides you with what we call the magnitude. The magnitude is also known as the modulus, and it's also known as the quantity. So if I give you a number to describe where I am, I'm giving you a sense of quantity. And this would apply to things like speed. If I want to tell you distance like I did here, it can apply to energy as a quantity, and on and on and on and on. However, when I'm talking about a vector, I'm talking about a scalar quantity again, but with a sense of direction. In other words, here I can, if I'm this person again, and I want to tell you where I am, I'm going to tell you I'm 20 meters to your right. So there will be this pointing arrow to tell you the direction I'm in. Or it can be not just east, right, or I can tell you I'm 0 degrees to your right. I'm 20 meters and 0 degree, so this is where I'd be. Or I can tell you I'm 20 meters to your 90 degree or to your north, etc. The point of vectors is that it gives you not only the magnitude, but it also gives you the direction. And so when it gives you the sense of direction, this can be in angles, in right, left, in east, west. It can be in so many things. So that's the basic difference between scalar quantities and vector quantities, and this outlines its importance. When you're told a sense of direction, it's more accurate, because if you noticed here, when I tell you I'm only 20 meters away from you, I can be in any point on this circle. In other words, I'm giving you infinite possibilities. When I'm telling you here about vectors, I'm 20 meters to your right, there's this only one single point in the universe that I can be on. And that is again why vectors are important. Now that you do know what a vector is, I can move on to tell you what we're going to discuss in this tutorial. Now, in this tutorial, we're going to give you cases and properties, but we're going to start with properties so you'll be able to solve the cases. But before moving on, I want to just make sure you know something, which are vector representations. Now, vectors can be represented in so many ways, and they all work, but some of them are better than the others. So what are these types of representations? Well, here we go. First of all, to actually tell you we're talking about a vector, I can go and tell you that this is vector A. and draw a direction arrow above it, and this will indicate it's not scalar quantity but it's a vector quantity. Also, another thing I can do is I can write this A but underline it. And another thing I can do is that instead of the line under it, I can draw what it's called a tilde. So this is a tilde, if you wanna know. And that, oops, let me get back to our notes. Yes, here we go. And there's something else I can use to present, which is usually found in your books, and I don't know how to draw this here, but it's technically just boldifying your letter. When it's in bold, then it's a vector, and you can see the drop shadow is much bigger, so you know that I boldified it. Now, all these work, like you can use them all, but I personally prefer this one. Why? Because it's obvious. The direction arrow tells you that it's definitely a vector, and underlined can be confused when it's written on a paper with the lines on the paper themselves. I misspelled tilde. So yeah, and here you can do this, but again, it can be melted within the lines, and the bold is just no. It's very tiring to try to boldify letters in an exam. So yes, always use the direction arrow, but know that the other representations can be found, so you know how to read them. This is why they're important. Now, another thing about representations, when we write a vector, I want you to know that we say that vector A would it can be okay. We want to draw something we're going to be drawing over and over and over again in this tutorial, which is our graph. When we're talking about vectors, we have the graph like this, but this is not a human graph. Let's just try to be more straighter. Yeah. Here, this is not our x-axis anymore, it's called our y-axis, and this is not our y-axis, it's our j-axis. And if you want to talk in 3D, then you're going to have your other perpendicular axis here, which is not the z-axis, but it's the k-axis. So when you want to talk about a vector, you're going to talk about a magnitude in one of these directions. So you're going to say vector A is 3i plus 2j plus 3k. And if you want to write it in, you can represent it here like that in this format, or you can draw it in what we call a matrix form, where the top one will be your I, the middle one will be your J, and the bottom one will be your K. Now note that this is in 3D. Those are in 3D and they're interchangeable. If you want to do the 2D, you simply eliminate, let me use red, and yes, you eliminate the 3K and the 3 here in order to be 2D. And that would be how you represent your vectors, which can make us move on to our properties and our cases.